Welcome to this explainer. You know, the last time it rained heavily in your city, did you happen to watch all that water rushing down the storm drains and wonder where exactly is all this going? Today, we're diving into the South African REDBOOK guidelines to fundamentally rethink how our cities handle something as simple yet incredibly powerful as a single raindrop. For a long time, urban planners just treated rainfall as a nuisance, basically a hazard that had to be pushed out of our towns as fast as possible. But as we're going to see today, there's a massive paradigm shift happening right now in the world of urban design.
Today, we're looking at 5 key areas: rethinking the water cycle, a new paradigm called WSUD, the SuDS treatment train, source and local controls, and finally, the dual drainage system. We'll be tracking the journey of water from high-level planning right down to the literal street level.
Section 1. Rethinking the water cycle, the impact of urbanization. To figure out where we're headed, we first need to look at what happens when human settlements disrupt nature's delicate balance. Have you ever really considered what happens to rainwater when we take porous forests, wetlands, and fields and completely pave over them with impervious concrete, roofs, and asphalt? It sounds like a basic question, but the environmental consequences of literally paving over paradise are pretty staggering.
Think about it. In a natural system, a massive chunk of rainfall, usually around 85 to 90%, goes right back into the atmosphere through evapotranspiration. The rest naturally filters down to replenish our aquifers or flows safely into streams. It is this beautiful, highly efficient loop. But our traditional urban cycle completely short-circuits this process. With the ground sealed off by hard surfaces, infiltration just plummets, and we're left with these massive volumes of fast-moving, highly contaminated surface runoff. And here's the real kicker. Because we're just flushing that water away, the urban cycle forces us to rely heavily on importing treated, potable water from somewhere else just to survive.
The contrast on the ground is absolutely stark. On one hand, we can actively manage this excess water, treating it as a valuable resource to sustain things like productive community gardens. Or we can choose the alternative. Unmanaged water inevitably becomes a destructive force. If we just let it run off, it causes severe soil erosion, sweeps concentrated urban pollution straight into our rivers, and rapidly degrades the whole local environment.
To fix this damage, we basically need a complete shift in our engineering mindset. Which brings us to Section 2, a new paradigm, WSUD, or Managing Water Wisely. WSUD stands for Water-Sensitive Urban Design. The core philosophy here is actually pretty simple, but it's an absolute game changer for urban planners. It means treating stormwater not as some hazardous waste that we have to pipe away immediately, but as a vital, scarce resource that we absolutely have to integrate back into our settlements. The ultimate goal? To seamlessly mimic that natural water balance we just talked about, boosting infiltration, increasing evapotranspiration, and drastically cutting our demand for imported water.
Section 3. The SuDS treatment train, a sequential defense. So how do we practically pull this off in our own neighborhoods? We use sustainable drainage systems, or SuDS. When engineers implement SuDS, they're carefully balancing multiple competing objectives. Historically, conventional drainage only cared about one thing: quantity. Just get the water out of here. But SuDS brings 3 completely new pillars to the table: quality, amenity, and biodiversity. We categorize these interventions into source, local, and regional controls. Now, notice how local and regional controls, like constructed wetlands and bioswales, consistently deliver high value across all 4 of these categories at the same time. By integrating these naturally inspired systems, we're turning strictly functional, boring drainage infrastructure into beautiful, biodiverse spaces that actually elevate the whole community.
The really crucial takeaway here is that SuDS isn't just a single tool. It's what engineers cleverly call a treatment train. You don't just dump one massive concrete drain at the bottom of a hill. Instead, you string different, progressively larger interventions together. This localized network works together to clean the water of pollutants and gradually slow it down as it moves step by step through a city, mimicking the natural friction it would have encountered in a forest.
Section 4. Source and local controls, managing the raindrop. Let's see what this looks like in practice, right from the second a raindrop hits a driveway.
The treatment train starts with source controls, meaning we manage the runoff right inside the boundaries of a private property. Capturing it directly with a rainwater harvesting tank intercepts the drop immediately, giving you supplementary on-site water for irrigation or washing. Or, by using permeable interlocking pavements instead of solid asphalt, the stormwater drains straight through the surface and into a storage layer underneath. This promotes natural infiltration exactly where the water lands, well before it can build up any speed.
So by managing water right at the source, we're drastically reducing the sheer volume of water that eventually hits our public streets. We take the pressure off the municipal system, while at the same time, we create a supplementary water supply for the property owner and help recharge the local groundwater levels. It's literally a win-win for both the homeowner and the broader ecosystem.
But, what if the storm is really heavy and the water makes it past the property line? Well, that's when it meets our local controls. Things like rain gardens and bioswales become our second line of defense. You'll typically find these strategically placed in public areas, like lining our sidewalks or integrated into neighborhood parks.
And it's important to understand that these aren't just pretty roadside gardens meant to look nice while you walk the dog. These are highly technical, rigorously engineered landscapes. They use carefully selected filtration media, specific plant species, and even complex underdrains to filter out harmful pollutants, absorb biological nutrients, and temporarily detain surface water. They're doing incredibly heavy lifting to slow down the runoff before it can degrade rivers downstream, all while acting as an aesthetic enhancement for the neighborhood.
But we've got to be realistic here. What happens when we get hit with massive, severe storms that totally overwhelm these localized green controls? Section 5. The dual drainage system. Handling the extremes.
In South Africa, the law actually requires urban planners to meticulously map out the 1 in 100-year floodline. This is a critical, legally binding metric. Engineers have to predict these incredibly severe recurrence intervals because the stakes are just so high. They're designing systems to protect critical infrastructure. Think sewage treatment works, cemeteries, and solid waste sites, as well as human dwellings from catastrophic, life-threatening floods.
This is exactly why modern infrastructure relies on a dual drainage system. The minor system, which includes those clever SuDS controls we just talked about, along with standard pipes and culverts, handles your frequent, everyday rainstorms. But the major system kicks in during severe, infrequent events. And here is the truly fascinating part. The major system intentionally uses the road network and open spaces. It actually turns places like parks and sports fields into temporary retention lakes to safely route severe floods overland to a safe point of discharge.
So the overarching engineering logic completely shifts depending on the weather. For small, frequent storms, designers rely on volume-based sizing to ensure water quality and protect those downstream natural channels from slow erosion. But as the storm gets bigger and we face larger, less frequent events with massive, surging peak flow rates, the logic flips entirely. Designers transition to flow-based sizing to manage those massive, violent surges of water that could otherwise tear right through a city.
When we hit those extreme, major storm zones, the whole engineering philosophy essentially abandons filtration and conservation for a single critical mandate, D3, don't do damage. At this stage, it's not about watering community gardens or filtering sediment anymore. It is strictly about minimizing property destruction and entirely eliminating the risk to human life.
As we wrap up this explainer, I want to leave you with a thought that challenges how you view your own environment. We've seen how the paradigm has shifted from simply pushing water away to actually capturing and treating it as a resource. So next time a heavy storm rolls in, will you look out your window and just see a hazardous nuisance flooding the pavement? Or will you see a vital, life-giving resource making its way step by step through your neighborhood's treatment train? The difference between the two is really just good design. Thanks for joining me on this explainer, and keep observing the world around you.